I welcome you all in online sport program for class 9 subject physics, chapter physical quantities and measurements. Today we are going to revise some questions from exercise. Question number 1. Encircle the correct answer from the following options. Number 1. The number of base units in SI are, as we know, there are 7 base units: length, mass, time, electric current, intensity of light, temperature, amount of substance. So, option C, 7 base unit is correct. Which one of the following units is not a derived unit? Option B, kilogram, is right option because mass is a base quantity whose unit is kilogram. Amount of substance in terms of number is measured in mole. An interval of 200 microsecond is equivalent to option C, 2 into 10 raised to power minus 4 seconds. An interval of 200 second is equal to 2 into 10 raised to power minus 4 seconds because mu is equivalent to 10 raised to power minus 6 and 200 can be written as 2 into 10 raised to power 2. So by solving 10 raised to power minus 6 and 10 raised to power 2, we will get 10 raised to power minus 4. Which one of the following is the smallest quantity? Option D, 500 nanogram. Nano is equal to 10 raised to power minus 9. So it is the smallest quantity. Which instrument is most suitable to measure the internal diameter of a test tube? Option B, vernier calipers, because its least count is 0.1 millimeter. Next question is, what is the difference between base quantities and derived quantities? Give 3 examples in each case. Base quantities are the quantities on the basis of which other quantities are expressed. The quantities that are expressed in the term of base quantities are called derived quantities. Base quantities are length, mass, time, electric current, intensity of light, temperature, amount of substance. Base units are meter, kilogram, second, ampere, candela, Kelvin, mole. Derived quantity are speed, whose unit is meter per second, acceleration, whose unit is meter per second, volume, unit cubic meter, force, whose unit is Newton, pressure, whose unit is Pascal, density, whose unit is kilogram per cubic meter, charge, whose unit is coulomb. Now find out base quantities involved in each of the following derived quantities. Speed. Speed is a derived quantity and its mathematical form is meter per second, whereas meter is the unit of length and second is unit of time. So the base quantities involved in speed are length and time. Volume. Volume is equal to length into width into height, as width and height basically indicates the length along the particular direction. So the base quantity involved in volume is length. Next is force. Mathematical form of force is ma. As we know, acceleration is equal to rate of change of velocity, means Vf minus Vi divided by time, whereas the unit of velocity is meter per second. and the unit of time is second. Unit of mass is kilogram. So force is equal to kilogram meter per second square, whereas the base quantities involved in force are mass, length, and time. What role SI units have played in the development of science? SI units have played an important role in the development of science. This system facilitates the students to understand different units and also to understand their mutual relationship. It became easier to convert one unit into other, which facilitate the scientific research. Using these SI units, we can also understand that what physical quantities are involved in any derived quantity. The 11th General Conference on Weight and Measures, held in Paris in 1960, adopted a worldwide system of measurements called International System of Units. This international system is commonly referred as SI. What is meant by vernier constant? The difference between one small deviation on main scale of vernier caliper and one vernier scale deviation is 0.1 millimeter or 0.01 centimeter. This is called the least count or vernier constant. It is the difference between one small main scale deviation and one vernier scale deviation. Least count of vernier caliper is also found out by using this formula: smallest reading on main scale divided by total number of deviation on vernier scale. Smallest reading on main scale is 1 millimeter, whereas the total number of deviation on vernier scale is 10. So 1 divided by 10 we will get 0.1 millimeter, which is equal to 0.01 centimeter. Least count of vernier caliper is also called as vernier constant. What do you understand by the term zero error of measuring instrument? Zero error is basically the systematic error which exists in measuring instrument. This is the error in measuring instrument due to which it shows measurement more or less than the actual measurement. This error can be solved by adding or by subtracting. In measuring instrument like vernier calipers and screw gauge, there are two scales. Before taking measurement, if zeros of both scales do not coincide, then these instruments either give more reading or less reading than actual measurement. So this error in the measurement is called zero error. Next is why the use of zero error is very important in measuring instrument. So the use of zero error is very important in measurements, otherwise our measurement would be inaccurate because this error affect all the measurement taken by the instrument. To get accurate measurement, zero error is calculated and then zero correction is done. So zero error is necessary in the measurement for accurate result. What is a stopwatch and what is the least count of mechanical stopwatch you have used in laboratories? A stopwatch is an instrument which is used to measure the time interval of an event. Least count of mechanical stopwatch is 0.1 second. There are two types of stopwatch, mechanical and digital. Mechanical can measure up to 0.1 second or 1 by 10 second, and digital can measure the time up to 0.01 second or 1 by 100 second. So next question is, how do the prefixes micro, nano and pico are related to each other? As we know, the micro is the biggest unit, followed by the nano and then pico. 1 micro unit is equal to 10 raised to power minus 3 nano unit, which is further equal to 10 raised to power minus 6 pico unit. 1 micro is equal to mu, which is equal to 10 raised to power minus 6. 1 nano is equal to 10 raised to power minus 9. 1 pico is equal to 10 raised to power minus 12. We know micro is equal to 10 raised to power minus 6 and nano is equal to 10 raised to power minus 9, which can be written as 10 raised to power minus 6 into 10 raised to power minus 3. Whereas 10 raised to power minus 6 is equal to micro, so we will get 1 nano is equal to 10 raised to power minus 3 micro. 1 pico is equal to 10 raised to power minus 12, which can be written as 10 raised to power minus 6 into 10 raised to power minus 6. Further, we can written as 10 raised to power minus 6 micro. 1.6. On closing the jaws of vernier calipers, 0 of the vernier scale is on the right to its main scale, such that fourth division of its vernier scale coincides with one of the main scale division. Find its zero error and zero correction. So given data is vernier division coinciding with main scale, which is represented by n and is equal to 4. The least count of vernier scale is 0.01 centimeter. Main scale reading is 0.0 centimeter. We have to find out zero error and zero correction. Solution. The main scale reading is 0.0 centimeter. To find out vernier scale reading, multiply the least count of vernier scale with vernier division coinciding with main scale. Least count is 0.01, whereas vernier division is 4, so we will get 0.04 centimeter. Since 0 of the vernier scale is on the right side of the 0 of the main scale, thus the instrument has measured more than actual reading, it is said to be positive, zero error. The 0 of the vernier scale is on the right side of the main scale 0, so zero error is positive. Zero error is equal to plus 0.04 centimeter. Note, if zero error is positive, then correction applied will be negative and vice versa. So zero error is plus 0.04 centimeter and zero correction is equal to minus 0.04 centimeter. A screw gauge has 50 divisions on its circular scale. The pitch of screw gauge is 0.5 millimeter. What is its least count? Given data is number of divisions on circular scale, which is represented by n and is equal to 50. Pitch of circular scale is 0.5 millimeter. We have to find out the least count of screw gauge, and we know least count is equal to pitch of screw gauge divided by number of divisions on circular scale. Pitch of screw gauge is 0.5 millimeter. Number of divisions on circular scale is 50, so we will get 0.01 millimeter. To convert this value into centimeter, divide 0.01 millimeter by 10. We will get 0.001 centimeter. Write the following quantities in standard form, means you have to write these values in scientific notation. First is 6400 kilometer. In this point, a decimal will be moved from right to left towards the first non-zero digit, and it will become 6.4 into 10 raised to power 3 kilometer. In this, again, decimal will move from right to left towards the first non-zero digit, and it will become 3.8 into 10 raised to power 5 kilometer. In this, again, point from right point will be moved from right to left towards the first non-zero digit. So it will become 3 into 10 raised to power 8 meter per second. In D, seconds in a day, as you know, in a day 24 hours will be multiplied with 60 minutes, will multiply with 60 seconds. So we will get 86400 seconds. Again, point will move from right to left towards the first non-zero digit. It will become 8.64 into 10 raised to power 4 seconds. This is all about today's lecture. Thank you for listening.